Hello. I was doing this question just now, and I was midway through editing until I figured out halfway through my audio cut out. So I have to do it again. So let me just try explain. So numbers with same consecutive differences. Return all non-negative integers of length n such that the absolute difference between every two consecutive digits is k. Right, so for example, if you have 181, 292, you see that the differences between 8 and 1 is 7, which is k. So it has to be true for all of these numbers. And you want to return all possible combinations given any pair of n of k in between, where n is between 2 and 9 and k between 0 and 9. So if you have n is equal to 9 and k is equal to 1, then the possible combinations would be a lot, right? There could be a lot. You could have 0, 1, 0, 1, 0, 1. Yeah, you can imagine. What if n is equal to 2 and k is equal to 9? Very few in this case. Well, we could have 9, 0. We also could have 0, 9. But 0, 9 starts with a 0, so leading 0. We don't want leading zeros. Note that every number in the answer must not have leading zeros. So how do we do this? We could probably try it like a brute force approach because the bounds are kind of low. Although, let's think about the time complexity of a brute force approach. So if n is equal to 1, then that means we have all the numbers from 1 to 9. So let's just say there's around 10. For n is equal to 2, we could potentially be doubling the number of possible answers in the subproblem of n is equal to 1. So that means we have up to 20 numbers. And then if n is equal to 3, we could be doubling all these answers to get 40, and then 80, 160, and so on. But how many of these do we have? Well, this would correspond to n is equal to 1, so n is equal to 2, 3, 4, 5, 6, 7, and so you have up to n equal to 9. Well, this is equal to, let's say, 10 times 2 to the power of 0, right? And this is equal to 10 times 2 to the power of 1. This is equal to 10 times 2 to the power of 2, and so on and so forth. We have up to 2 to the power of 8. So the maximum number of the sequence would go up to 10 times 2 to the power of 8. Let's just say 2 to the power of n. We could say 2 to the power of n minus 1, but let's just say 2 to the power of n. And this 10 is just a constant. So we could say it's around 2 to the power of n, but we have around n of these that we need to sum up. 10 plus 20 plus 40. So let's just do n times that. Okay, so that's an upper bound on the time complexity. What is this value actually equal to if we sub in n to be equal to 9? So we have 9 times 2 to the power of 9, which is 4608. Is that correct? Yes. But then we also need to multiply by 10, make it a little bit more accurate. So we get, 46080, which is definitely doable. So let's just take this as our time complexity and try to implement it. But we've already kind of talked about this in terms of subproblems. So let's just continue on that thought. If our subproblem is nk, then how do we leverage off subproblems to come up with the answer for nk? Well, it would be equal to a set of numbers where we have n minus 1k. So we use the same difference, but we have one less length strings or numbers. We know we need to add an extra digit. It would be the last character or the last digit. So let's say we're considering one possible answer from the subproblem at I, and we consider the last character at this position. Then we need to add k to it. That's one possible answer if ended digit is in the range of 0 to 9. And then we also have another one where we have minus k here. And do this for all I in 0 to the length of n minus 1k of the subproblem. Right, that kind of makes sense, right? We need a recursive function that returns... It's easier to work with strings, actually. And then at the end, so let's call it a helper, takes in an int n and an int k. Here I could just say a vector of strings is equal to helper at nk, right? Let's call this sequence. And then we could go through and create our answer vector. Go through all of the strings in the sequence and answer.pushback, convert the string to a number, and then return the answer. Alright, so that's the main function done. Now we're just for the helper part. So whenever you make these recursive functions, you always need to think about the base case first, which in this case would be if n is equal to 1. Because if n is equal to 1, we see that that's actually not a valid case because n is between 2 and 9. If n is equal to 1, then you have 9 answers from 1 to 9. So we could just say for int I is equal to 0, of 1, I less than 9, plus I. Let's make a string answer. Well, let's call it result. And we could do result.pushback I. Let's do it to string I, convert it to a string, and then return answer. In the case where n is not equal to 1, we have n greater than 1, in which case we do the exact same, the logic we had here, which was, let me put it up here. So we can get the subproblem's answers from calling helper nk at n minus 1. Go through each of the strings, auto const and s in sub, should be result. First of all, get the last character, which will be a char, from s. So you go s.size minus 1. And then we figure out what's the next char to append to this string. And that would be the last character that we just figured out plus k or minus k. So say char a is equal to the last plus k. We also have char b is equal to last minus k. If a is in the range of 0 to 9, then we could append it to this string. So since a is plus k, we know that last is valid, so a could only be past 9 or within the range 0 to 9. You can say if a is less than or equal to the character 9, then add to the answer, do your result push back s plus a, and we could do the same for b. If b is greater than or equal to 0, then do this, then return result. There is one case we haven't handled, and it's the case where k is equal to 0. If k is equal to 0, then we're doing last plus 0, last minus 0, which means that a is equal to last, b is equal to last, and we're pushing back the same string twice. So here we could just have a if condition and say if k does not equal to 0, then push back another one, consider the other case. It should be from I to I less than or equal to 9. Okay, that seems to work. Let's test the case where we have 2 and 0, or like 9 and 0. Yeah, nice. And the very big case would be n is equal to 9 and k is equal to 1. Nice. Okay, let's give that a go. Awesome. I got 4 milliseconds last time. It's the exact same solution. Thanks for watching, and don't forget to give a like and subscribe. See you later.